Welcome to a crucial part of programming, making decisions. This is where Python becomes more than just a series of commands. It becomes smart. Think of Booleans as a simple switch, like a light switch that is either on or off. In Python, those two positions are called true and false. These values help us control the flow of logic in our programs. By the way, I'm using Jupyter Notebook for this lesson, but feel free to use any IDE you are comfortable with. Python works the same everywhere. Let's jump in. You can think of true as the light switch turned on and false as the light switch turned off. But here is the trick. Python also treats true as 1 and false as 0. That means Booleans can do more than just turn logic on or off. They can participate in operations you had normally associate with numbers. Let's test this out with some hands-on coding. See how true acts like 1 and false like 0. This might seem small now, but this will be huge when we start building real-world applications. Just like storing numbers or text, you can store Boolean values in variables. Imagine we have two switches in a room. One controls the light and the other locks the door. Here, is light on is true, meaning the light is on, and is door locked is false, meaning the door is unlocked. Let's combine these switches for more interesting logic. This is where things get exciting. You can combine these Boolean switches to make decisions in your programs using logical operators. And both switches must be on. Both conditions must be true for the result to be true. Or, if at least one switch is on, the result is true. Note, this flips the switch, turn true into false, and vice versa. Let's see this in action. See? You're controlling the flow of logic in your code. Let's take this further. Booleans are also great for comparing values, like checking if two things are equal or greater. This is called comparison. Every time you compare something, Python gives you a Boolean result, true or false. Let's do some comparison. You will use this comparison a lot when you start making your programs decide what to do based on values. Now, let me warn you about a few common mistakes when working with Booleans. Confusing equal to with the double equal to. One is for assignment, the other is for comparison. Mixing them up can lead to confusing bugs. Try this example in your notebook. Overcomplicating conditions. Keep your Boolean logic simple, or it will become hard to debug. Watch for implicit Boolean values. In Python, many values like 0, none, or empty list are considered false. This can be useful, but also tricky. Now let's build something real, a basic user authentication system. This system should grant access only if both the username and password are correct. There you have it. Try flipping both values to true and see what happens. Only when both are correct will the user be authenticated. Boolean logic isn't just limited to these simple checks. Behind the scene is part of something called Boolean algebra, which forms the foundation of digital circuits and computer science. While we won't dive deep into Boolean algebra, just know that everything we are doing here is part of a larger world of logical reasoning. In our next lesson, we'll explore the mighty if statement, where you will really learn how to make decisions in your programs based on these Boolean values. It's a game changer. Stay tuned because this is where programming gets truly interactive. And as always, if you've learned something new today, hit that subscribe button and smash that like button to support this channel so that you never miss the next lesson. See you soon.